Hello, this is section 5.3 hyperbolas. So objective is number one, standard form of the equation of the hyperbolas and graphing hyperbolas and finding the equation of the hyperbolas. A hyperbola equation, the definition of the hyperbola is a set of all points in a plane. The difference of which of the distance from the two fixed point is a constant. So the only word in this definition different from the definition of the ellipse is the word difference. In general, hyperbola, because ellipse we use a sum of the two fixed points, and then this is the difference, okay? So in general, hyperbola can be seen as an ellipse that is cut in a half vertically or horizontally and turned inside out. As depicted in each of the following graphs, hyperbola will either open up and down or left and right. All right, so the difference between the hyperbola and the ellipses, there's a negative sign in the hyperbola, okay? And then the A doesn't have to be the B bigger than the B this time, okay? So center is H and K, okay? And then the A square actually determines the vertices, okay? So let's say your center is a 0, 0. And then you go to A unit to the right and the A unit to the left to get the vertices. So this is A unit, okay? A units and A units. And then you go to B unit, but B could be the bigger than the A though, okay? But let's say we're about here. So this is the B units and this is the B unit, okay? It's about B and the negative B. And then you need to draw the rectangle this time instead of the ellipse you have, okay? If you put the rectangle, then once you have a rectangle, we can get to the diagonal dash line, which makes the asymptotes. Diagonal line. And then the ellipse is always coming from the vertex, okay, which is A. So this is a hyperbola, okay, for this case. But for the next one, center, of course, is H and K. So which is H here and the K is here this time. And then, of course, A determines to the vertices, but this time is on the vertical, okay? So from the center, you go A units up and A units down. Okay, and then it could be a B is bigger than A too, okay? So B is right here. And then about same units, you go to negative B here. And then make a rectangle. Go through those A and B points. And then you can make the vertical, the diagonal dash line. Then I said your hyperbola is away from the A, so your graph should be this way. Okay, so the asymptote is very important for this case, okay? Alrighty, next one, next page. The list of the components involved with the hyperbola will include the following. So foci, two fixed points placed side by side or up and down from each other. To center the midpoint of the line connecting the two foci, also the midpoint of the vertices. And then number 3, vertices, the 2 points where the line through two foci intersects the graph of hyperbola. Consulting the text for the derivation of the standard equation of the hyperbolas, we have the standard equation of the hyperbola with the center H and K and the foci side by side, as we do here. Okay, so this, something is wrong here. Sorry about that. This must be A squared, and this must be B squared. What am I doing here? A squared is always positive term. And then similarly for the hyperbola, which opens up and down, because the four sides are located one above the other. So we obtain the second version for the equation of the hyperbola as y minus k squared over a squared this time, minus h minus x minus h squared over b squared equal to 1. So graphing of hyperbolas, we will introduce the general process of the graphing hyperbola. We will include a simpler way to determining the width and controlling the asymptotes. So I just write down the formula here, okay? And then the center is h and k always. Be careful to see that the h is always a value that is a binomial expression with the variable x, and k is always with y. Number 2, determine the value of a, the distance from the center to the vertices. Use this value to label the vertices. If a square is under an expression involving x, then the vertices will be the left and right from the center, the same direction as the x-axis. If a square is under the expression involving y, the vertices will be up and down from the center and the same direction as the y-axis. Number 3, determine the value b. Use this value to mark 2 points distance of the b from the center, in the opposite directions from the center as the vertices. Number 4, draw a dashed rectangle that passes through the 4 points. Find step 2 and 3, and draw the 2 lines through the center and the hyperbola and outward toward through the center of the rectangle. These are the asymptotes. And then from the vertices, draw the 2 curves. The hyperbola approach the asymptotes as they move away from the vertices. So use this formula we have. This is different from the ellipse. To determine the value of the c, to label foci, 2 points and distance c from the center, and the same direction as the vertices. Okay, so example 1, so graph. So this time, of course, center is 0, 0. Because there's no change of x and y square. And then this time is a squared is 4. Just look at the positive term. Not a 9 this time, okay? Which means a is a plus minus 2. Determine the vertices, okay? So from the center, 0, 0. And then the 4 come with the x squared, so you got the horizontal axis, okay? So you go to 2 units to the right and 2 units to the left, okay? So this is a vertex 1 and vertex 2. And then we use a b square, which is 9, to get the endpoints, okay? So 1 and 2 and 3 right here. And then 1 and 2 and 3. So this is another co-vertices, okay? Which is not that important for the... Alright, and then draw the rectangle. And then we just get the diagonal. Diagonal go through the... And then your hyperbola is coming from here. And then where's the foci? Actually, the foci is a formula is a c squared equal to a squared plus b squared, just like So a squared is 4, b squared is 9, which is 13. So c is actually plus minus radical 13. So which is about radical 13 is about 3.6. So 3.6 is from the center, 1, 2, 3, about here. So this is a focus 1, so from here, 1, 2. Yeah, this is a focus 2, so 3.6. All right. Okay, so it's the c square is c is bigger than the longer distance from the center than the vertices. Okay. Okay, example 2, the graphs. So the center this time is x from here. So h is 1 and negative 2. A squared is 25 because 25 is constant term. So a is a plus minus 5. And then b squared is 16. So b is a plus minus 4. So center 1 and negative 2 right here. And then you go up to 5, okay? So because 25 come with the y this time, okay? So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 right here. And then you go 4 to the right from the center. So 1, 2, 3, 4. Go here 1, 2, 3, 4 right here. And then make a rectangle go through those points you found. And then diagonal. And this time is the center is right here, right? So this is the vertices, okay? Vertex 2. And then you got your ellipse right here. Okay, so this time for the foci, which is c squared equal to a squared plus b squared. So 25 plus 16, which is 41. So c equal to plus 25 equal 41. So radical 41 is 6.4. So you got here 6.4. So this is a 1, 2, 3, 4, 5, 6.4 about here. So foci 1, we are 1, 2, 3, 4, 5, 6.4 about here. So foci 2. So along with the same axis, okay? With the vertices and the center and then the foci all goes together. All right, example 3. Graph 2x squared minus y squared plus 4y minus 12 equal to 0. Okay, so I'm going to put the 2x squared minus y. Oh, I don't need to do anything, okay? Equal to 12, okay? I'm not using that. So I got 2y squared and then subtract the y squared minus 4y. And then I'm going to complete the square, right? But this time I have to subtract to something for the inside of the number, okay? Okay, because it's negative 1. So, one number, so negative 4 is a b divided by 2, negative 2 square 4. Okay, so I get minus, complete the square, y minus 2 square equal to 8. And then I divide by 8. And then on y is equal to 4 minus, oh, sorry about that. Why am I saying y square? My fault. It's gotta be our x. And then y minus 2 squared over 8 equal to 1. Okay, so center is a 0 and 2. So 0 and 2 right here. So this is center. And then a squared, of course, is a 4. So a is a plus minus 2. B squared is 8. And b is plus minus 2 at 2. So approximately, we're at 2 is a 2.8. Alright, so I got center is 0, 2. And then I go to the right to get a vertex 1, 2. So vertex 1, 1, 2, vertex 2. And then go 2.8. So 1, 2, 2.8. And then down 2.8 right here. And then I got the rectangle. And then diagonal. And then I say you're hyperbolize from the vertex. And get close as into 2. Alright, that's a graph. And then c squared equal to a squared plus b squared. A squared is a 4 plus a 12. So c is a plus minus radical 12, which is 2 radical 3. Yep, that's all. Alright, example 4. Find the center and the direction on the following hyperbola opens by the converting 4x squared minus 3y squared plus 8x plus 18 minus 11 equal to 0 to stand up. Okay. Alright, so I have a 4x squared plus 8x together minus 3y squared plus 18y. And then add 11 both sides. And then I have factor out the grouping. Change the sign. I got 4 factored out x squared plus 2x. 1. Pulled out the 3 of y squared minus 6y. And 11. Then of course I have to multiply 4 something with a minus 3 something, okay? So in here, b is a 2 divided by 2, 1. 1 square is a 1, which is 1. And then I have a b is a negative 6 divided by 2, negative 3 square 9. So I got 9 and the 9, okay? Then I got 4 of x plus 1 square minus 3 of y minus 3 square, which equal to 11 plus 4. 11 plus 4 minus 27, which is negative 12. So if I divide by negative 12 both sides, because I need to get positive 1, I got negative over 12, 3, right? So I got x plus 1 squared over negative 3. And 2 negative become positive. And 3 goes 12, 4. Y minus 3 squared over 4 equal to 1. So if I'm writing it right, y minus 3 squared over 4 plus x plus 1 squared, oh sorry, should be the negative, right? Minus over square root of 3 equal to 1. Yeah, that's the hyperbola. Okay. So center is going to be negative 1 and 3 this time, okay? So h is from here, and then y is from here. Find the equation of the hyperbola. The final topic regarding hyperbola will the questions that is starting with the given information about the graph of the hyperbola while asking us to find the equation. So find the equation in standard form of the hyperbola with the vertices at that and the both sides as a 0 and 10. So, which is, when I rough graph, 0 to 6 is vertex 1 and 6 vertex 2. Foci about here. And then foci is over here. Okay, so the A must become with a Y, okay? So I think I need to write the formula as y minus k squared over a squared, subtract x minus h squared over b squared equal to 1. Okay, so center is the midpoint between the two vertices, which is a 0, 0 this time, okay? Alright, so h and k is a 0, 0, okay? So y minus 0 squared over a squared and x minus 0 squared over b squared equal to 1. And also, the a is the distance from the center to the vertex, which is a 6. So 6 is a squared is a 36. So I got y squared over 36 and minus x squared over b squared equal to 1. And then in order to find the b squared, I need to use the formula of ac squared equal to a squared plus b squared. Because the center to the foci, which is a 10, which is 10 squared equal to a squared 6 squared plus b squared. So 100 equal to 36 plus b squared. Subtract 36 both sides. 64 equal to b squared. Oh, so we got b squared, right? So your formula is y squared over 36 minus x squared over 64 equal to 1. So that's the hyperbola that we're looking for. Alright, next one. Find the equation in standard for the hyperbola with the vertices at the negative 1 and 2 and 7 and 2 and the asymptotes with the slope equal m equal to plus minus 1. Okay, so asymptote mentioned, I should say that it's gonna be depends on the slopes we have. But first of all, when you have a hyperbola, one is a negative 1 and 2 right here, which is a vertex. And then 7 and 2, so up to 7 here, about here. Okay, so this is the vertex and this is the vertex. Okay, so we need to find the center as a midpoint. So center, which is h and k. So h is midpoint point the two axes from the vertices. Okay, so negative 1 plus 7 over 2, 6 over 2, which is okay. Is 2 plus 2 over 2, 4 over 2, which is a 2. Okay, so h and k is 3 and 2. And then, since it's asymptotes, okay, so center is a 3 and 2, about here, okay. And then the distance from the vertex to here is going to be the A. So this is a 3 and 2, which is, this is a 7 and 2, so this is a 4, isn't it? So A is a 4, which means a squared is 16. So the slope is going to be the plus minus 1. So which means this time is the slope is actually you gotta see the slope is always what the change in y is over change in x. So 4 is a change in x, okay? So it's gonna be the b over a this time. Change y, okay? So which is plus minus, actually the a is a 4. Okay, now we have to find the b, okay? So I have, let's say 1 equal to b over 4. So b is a 4, right? So, oh, this is times a's and b's are same, isn't it? Okay, and then in other way too. Negative 1 equal to negative b over 4. So b is a 4 too, isn't it? So which means what? B squares are 16. Oh, so a square and b squares come out the same this time. All right, so we have a formula. This time is on the side, right? And x minus a squared minus y minus k squared over b squared equal to what? So x minus 3 squared over a squared is 16. Y minus 2 squared, b squared is 16 also too. It's okay. You can have the same a squared, b squared too, okay? There's no problem with this. All right, so that's all. Thank you for listening.